So last lesson of this unit, a very short unit, types of experiments. And there are 3, completely randomized, block, and matched pair. We've already discussed completely randomized. In a situation, we would take our volunteers, say 30 of them, 15 would receive randomly 1 treatment, say treatment A, the other 15 would be a part of a control group. So I'll say P for placebo. And then we would analyze the results and compare. The block adds an extra step. CR or CRD is completely randomized design. The block will add an extra step. What we will do is we will, instead of going straight from our volunteers to the treatments, we will separate our volunteers into groups. We will put them into blocks. So example, I will take my 30 and then I'll say, hey, we'll take 15 of those who are, say, males, and then 15 of those who are females, or we'll separate them by age, or we'll separate them by height, separate them by weight, separate them by whatever measure that you want to separate them by. And it doesn't even have to be 2 groups. It could be 3 groups, 4 groups, 10 groups. But we go into groups, and let's just say we'll go with male and female here. From that block, then you randomize your treatment, where half of them will receive treatment A, and the other half, so I have 7 and 8 to make 15, will receive the placebo or a control. And then the females will have half that receive the treatment and the other half that receives the placebo. And that then gives you results, and it gives you lots of results. It gives you results about the difference between your treatment and the placebo for all of your groups, which means you have a lot more comparisons and a lot more conclusions that you could make, because you, instead of just said blindly, let's go treatment or control, instead I could say males aged 30 through 40 who received this definitely improved compared to the placebo group, which is in comparison to females aged 18 to 25 who received this treatment. They did not show that much improvement at all. So all of a sudden, block just makes things a little bit more in-depth. So it adds more depth. Question?
Would it only be like one group? Could you separate them from males and separate them by age?
Exactly. Yeah, you could keep going. It would just be by grouping before we apply treatments. Group before treatment. Separate by group before we randomize our treatments. Okay, then we have a matched pair. Matched pair, there's 2 types of matched pair. Okay, it's either give everybody both treatments. Instead of sending one group one way and giving them a treatment, and then sending the other group the other way and giving them placebo, we say, you know what, let's just see on an individual basis how we respond. So we give individuals both treatments. Or people who are like the same person. Okay, so same age, height, weight, people who are like really, really close to being the same person, or at least the same in a specific type of way. We then treat those as the same person. We'll give one of them the treatment, one of them placebo. That may, there's possibly a better comparison between specific individuals. So I say, or match people up. and then give treatment. Matched pair can look anywhere from like we have our volunteer, then we will either assign them treatment A, then B in one order, and then we want to make sure that people also go treatment B, then treatment A in one order. It's important to randomize the order of the treatments with matched pair. That is if you're giving the same individual both treatments. If you are giving matched up people 2 different treatments, well then it doesn't matter, which one goes first. It does matter which goes first if you're going to give one person both treatments. I don't know what I was writing here. I said important. I like this orange. Important to randomize the application of treatments. Okay, and again, it should be some sort of like, in most cases, you want it to be single blind. You want, the doctor to give you, here you go, sir, you're going to take pill A. You're going to tell me how you feel after taking pill A for a week. And then after a week, I'm going to give you pill B. You're going to take pill B for a week. And then the next person's going to go, B then A. That way we can't have everybody do A then B, because that could create bias in our results, okay? So that's important. Here's the kind of formal definition of the both of them. It's exactly what you think. It might not make sense. So first we'll talk about the block design. We're going to divide our subjects into groups. So we add that extra element. We have our subjects in our box. We then split them into groups. And we can even split these groups into more groups, just like Ms. Martinez said. And then after we have the groups split up the way we want them, then we apply our treatment. It's A, B, A, B, A, B. Okay? And that's what you do. You're going to randomly assign the treatment to each group. You're going to go from there. It says you're going to use block if you have reason to believe certain groups will have different results. This is important. So if you believe that maybe males are going to respond differently to your treatment than females, go ahead and block. That way you can compare and conclude different things. If you think older people relative to younger people are going to have different results, then you should be blocking instead of just randomly applying the treatments from the start. Okay, it's just doing multiple completely randomized designs for experiments. This is funny, so you can't read it down here, but you can read it up there. Okay, so that was block, the formal definition of block. And now we have matched pair. Now matched pair, remember, it's either giving an individual both treatments, okay? So either the same individual receives both treatments. This is the typical matched pair. The individual is receiving both treatments, but we're going to make sure we're randomizing the order of the treatments. That is your typical matched pair. Or we matched up the type of person. Like we try to find identical twins, and we give them different treatments, and then we can compare their results. Okay, that's matched pair, making sure we see on an individualized basis the difference in results. Let's go back to that weightlifting experiment. And let's block it. So, remember the weightlifting experiment. We took 40 some odd kids. We then randomly assigned them to a heavy lifting, a medium lifting, or no lifting at all, and we compared the results of their muscle mass. How could we block that experiment?
Like their weight?
Yes, we can maybe block them by weights. Maybe we can say, hey, heavier kids, you go up there, you're going to go in one group, and then the lighter kids, you'll go in another group, and then we'll randomly assign you from there. What could be another way we could block it, Ms. Pushman?
By boys and girls.
We could block it by boys and girls. Maybe boys respond differently to weights than girls. What could be another way? Age. Maybe the young kids, maybe from 0 to like 5 and then 5 to 10. I think let's see what they do here. They are blocking by age. Sure, let's block by age. Do you have to block by age? No, you guys came up with a lot of different types of design. Instead of age, you could block by gender. We could have the males here. We could have the females here. And then we randomly assign from there. We could have done by weight. We could have over a certain pound compared to another pound, okay? And that's just providing you with more and more things that you can compare and conclude. It just makes your data a little bit more interesting with a little bit more results, okay? So that was block design of that situation. Now, what about a matched pair design? How could we take these kids with the weights and we could match pair design this experiment? Ideas. Sorry. What do you think, Mr. Holtz? No, this is the twins one. This is there's two options, Mr. Holtz. The option is you give each kid every treatment. That's one option. The second option is you find like the twins, the people who are the same, and then mix them up. What do you think?
You give one of the identical people lighter weights and another one heavier weights.
Sure, that's probably good. Probably you don't want to give each kid all three treatments where they're doing heavy weights and light weights, or then light weights and heavy weights, because like aren't you like naturally potentially building more muscle no matter what you're doing? So maybe that doesn't work out. I don't know. Maybe it does. I would probably go with more of the match up the individuals, have like as similar people as you could possibly have, and then put them into different groups and then assign the things. Let's see what they did. They are, okay, they're going straight match pair, which is give them two treatments. They said, we're randomly assigning them to two groups. 21 of them are going to be heavy load for 6 weeks, rest in 2 weeks, and moderate load for 6 weeks. And then the other ones are going to do moderate loads and heavy load. What I would do, probably not this. I like what we were saying is we were going to take the 43 volunteers and we can match pair this by doing, 21 similar people to the 22 people. Or I could just say that these people are similar, like this. Similar people in opposite groups. Can't type. Similar people in opposite groups. And then from there we randomize. Actually, we need to make sure that those similar people are all getting similar treatments. So 21 similar, they're going to receive, maybe 10 of them are going to go the heavyweights. 11 is going to go the moderate. Well, you have to do the same thing and match up. Okay. It's probably harder to do the matched pair with the similar people. It makes more sense to do, matched pair where you're just giving one person both treatments. But for certain experiments, you're just not going to match pair. Because like it doesn't make sense to lift one way for a bunch of weeks, take a break, then lift the other way. You're probably going to affect your results that way. All right. Which type of experiment should we use? We have a question: is the right hand of right-handed people generally stronger than the left? Mr. Murky of Murky Designs designs an experiment to test this question. He fastens an ordinary bathroom scale to a shelf 5 feet from the floor. At the end of the scale projecting out from the shelf, subjects are going to walk up to the scale and squeeze between their thumb and their fingers on the top. A scale which reads in pounds will be used to measure hand strength. So I guess the experiment is, are we stronger with our right hand than our left hand? Question. So let's say we did this with this class. There are 3 options that we can do. Okay? A completely randomized design would say, go up there and randomly you will either squeeze it with your right hand or you will squeeze it with your left hand. You will be told which hand to squeeze it with. Okay? And then we will look at the results of the right-handed versus the left-handed, see if the right hand is stronger. Okay? That's one way. That's the completely randomized design. A block design would say, okay, let's split you into males and females. All right, males, I will randomly assign you to squeeze the scale with my right hand, with your right hand, or squeeze the scale with your left hand. Okay? And then females, you do the same thing. So split up, randomly grab. Okay? That would be blocked. Matched pair would be everybody go up to the scale, and I will tell you which one to do randomly. Squeeze it with your right hand first, then squeeze it with your left hand second. Okay, so you do both treatments. You're squeezing with your right and your left, both treatments. Which way should we do it? Should we completely randomize it with random people grabbing with their right or the left? Should we block it, so we split into males and females, and then they randomly grab with their right or the left? Or should we match pair it, where everybody's grabbing with both their right and their left, and we're comparing those results? What do we think? What would be the best way to figure out if our right hand is stronger with our left hand? What do you think? Should we compare your right-handed poundage to my left-handed, and then if your right-handed is stronger than my left hand, we'll say, all right, people are probably stronger with their right hand.
You could be left-handed.
Maybe left-handed, maybe I'm just a stronger dude than you, Mr. Riley. Maybe you're stronger than me. I don't know. What should we do? Have everybody do it with both hands. We should probably match pair this and say everybody do both. Okay? Everybody test their right hand, and then everybody test their left hand. Or do it randomly. We will randomly decide if you're going to do right-handed or left-handed first. We will make sure that you don't see how strong one hand is versus the other, so that you don't try to top your score. Okay? And you'll compare your differences in hand strength. So that's the idea of a matched pair design. You can compare each individual with both treatments. I get compared with both the treatment of my right hand and my left hand. Let's look about another experiment. I have somebody who wants to grow corn on their field, and I want to compare the yield of 5 different corn varieties. So we're talking about seeds, and I want to see which seed is going to produce the most corn on my field. Okay? However, my field increases in fertility from north to the south. I realize that on the north end of my field, it grows just corn generally better than the south end of my field. What type of experiment should I do? Should I randomly assign seeds in locations on my field, like, 1/5 of it seed 1, 1/5 of it seed 2, 1/5, 3, 4, 5? Should I do that? So random locations, random seeds. That would be the random design. Should I do the block design, where I will separate it into blocks, my field, and then I will randomly assign the seeds to each block? So separate it into sections, and then have seed 1 in 5 different sections, seed 2 in 5 different sections, seed 3, 5. Or should I match pair, which is in each block I will plant all 5 corn varieties. and I'll see which one does best. You know, in each little area, I'll just make sure that I have every single treatment in every single area. What do we think? Which one makes the most sense? What do you think, Mr. Herzberg?
Since it's more fertile down at the north end of the field, I think that you should sort them out evenly.
So what kind of experiment is that? Is that matched pair, block, or completely random?
Block.
Yeah, I would say block 2. Block the field by location. And then randomly assign in each plot which gets the right corn variety. It doesn't say what time, right? Let's go during calf time. So here I see the north. I'll block this out, and then I will randomly assign, using a random number generator, the types of corn. We will see how well the seed does, each seed does in that spot. And then we can do the same thing here. We can do the same thing here. And so on and so forth. And probably what you want to do, instead of potentially making it random, you could almost match pair it and go like 1, 1, 1, 1, 1, and then 2, 2, 2. That way, like everything is in left to right and then north to south. That would give you even more comparisons. You would block it not only by north to south, but also east and west. So that's the idea with block. You just are able to compare. Maybe seed 1 is the best in really fertile land, but maybe seed 5 wins in infertile land that doesn't grow fast. So maybe seed 5 is the most resistant. Resistant something. I'm not a farmer. All right. What we're going to be doing next class is we're going to be doing some experiments. We're going to be doing a matched pair experiment and a blocked experiment. We're going to do a taste test of a generic versus a name brand for our matched pair, which means we are going to take, can't see where my dot is. We are going to take all of you students, we will randomly assign you to be eating a generic then a name brand, or a name brand then a generic. So that's match pair. You're all going to get both treatments. And then we're going to compare your preference. Okay? Do you prefer name brand things to generic things? Or do you prefer generic things to name brand things? Everybody's going to think they're going to prefer the name brand, but who knows? Maybe there's no difference. Probably it'll be single blind. We're going to discuss that more. We're also going to do a memory test next class. Okay? And it's going to be block. We are going to split you by personality. People who feel like they are more talkative, you're going to go in one block. People who feel like they are less talkative and more just visual and hanging out, you're going to go into another block. And we are going to test your memory on the block, and we will come up with different data, whether we are better if we talk more with memorizing things that are pictures or words, and then we are going to see if you are the less talkative person, if you remember things better with pictures or words, okay? That's what we are doing next class. However, this one is going to be pretty simple to run. My question, and we're not going to do this one, is, and you guys are going to help me, how should we run this taste test? I got a bunch of Fruit Loops and fruit spins, okay? And my goal is to show that people in general, or at least seniors in Lake Travis High School, will prefer the taste of Fruit Loops over the taste of fruit spins. And you guys are going to be my subjects. How should I run this activity? How do I run this experiment? Ideas. What do you mean? This is up to you. What do you think could be some factors that could create some incorrect experiences, some bias potentially? Sure. If you knew which one I'm putting in to like a cup or giving you, if I say, okay, here, try the Fruit Loop first, Mr. Herzberg. Okay. How did that go? Okay, great. Now try the Fruit Spin second. Do you think your answer might be influenced by that? Me telling you? Yes. Okay. So should we tell each other which one you're taking? No. So single blind. Good. We're going to make sure it's single blind. You don't know what you're getting. Okay. What also could affect our results? Ideas. Sure. Well, you're going to have a preference between one or the other, or maybe you're like, no, they're the same, they're not good. So that could be, so maybe like testing Fruit Loops is not going to be a good way to figure out whether generic versus brand name is going to be different. So maybe what should we do if we want to test, do people prefer generic brands or name brand brands? What should we do? Sure, maybe we should try to test other things that are generic or name brand. That's a good idea. Maybe we test other things and then we can see, oh, maybe it's just the Fruit Spins that people don't like, but other generics are good. Okay, so good. Now, let's go back to the Fruit Loops though. Do you think you can tell the difference by looking at it? Potentially. Maybe one's bigger than the other. Maybe these colors aren't as vibrant as these colors. Maybe vice versa. So what probably should we be doing if we're just going on taste? All right, maybe we'll blindfold. Okay, good. So here's what we're going to do. This is our study. You guys know that it's going to be single blind, so you don't know which is which. Okay? We are going to be blindfolded, which doesn't mean it's single blind. Blindfolded is just like cannot see. Okay? You will tell we're probably going to do this in pairs, so you're going to tell whoever you prefer. But what else needs to be, do we need to make sure, like, let's say I show up with two bowls, bowl A, bowl B, but I don't tell you which one is which, okay? And I give you A and B. Should we have everybody taste A first and then taste B second? Why is that bad, Mr. Johnson? Why is it bad for everybody to do A then B in that order? Sure. Maybe like tasting a Fruit Loop the first time is a better experience than the second Fruit Loop. So maybe it's just one of those things where like the aftertaste could affect the taste of your next Fruit Loop, right? So it's important to randomly assign the first one. So we'll flip coins. All right. And then, what was the key, Ms. Jameson, with what you said? We said, what if we don't like Fruit Loops? We're not going to be able to pick the difference between the generic and name brand. What else should we do? You said like, yeah, we should try different. Or test different generic versus name brand. So if you want to test something else besides Fruit Loops, you need to, on Monday, bring in a generic something and the name brand something. Now, we're not talking about like things that are similar. we're talking about, you know, the Hill Country Fair cheese, shredded cheese versus the name brand, I don't know, shredded cheese. You know, like we're talking about stuff where we're like HEB brand versus name brand. So it's very common in cereals, but it also exists elsewhere. Yes, Ms. Martinez.
So are we gonna have the whole class? And how is everything?
We're going to have the entire class to do this and the other experiments. Yes. Okay? This is our application of the experimental design. We think that name brand is the best. We will find out. Okay? So on Monday, bring in a generic and a name brand. If you want to. Okay? But, you know, if it's, and we only have 30 people, so we're talking about not like huge boxes of things, like small things. And we will all test. We will pick A and B. It'll be fun. It'll be good. We'll be able to do this quickly, I think, and come up with results. Okay? You guys cool with that? All right. We will start on our homework. Our homework is a worksheet as well as 3 book problems. There is space on the back of your worksheet to put the 3 book problems, so you do not have to break out another sheet of paper. Sure.